think are live decontrol. I think so. Perfect. All right. Okay, thanks everybody for coming out to ETHVan here on Thursday night at Decentral. Yeah, we've had a few things on the go here. We've been doing summer hours as of late. So we've been every second week is when we're showing up. And the next one that we're going to be doing will be middle of the month. Not sure who we've got speaking for that one, but the one after that, so the end of July, is we're going to have it on a Wednesday instead of a Thursday. Because, does anybody know why?
10 years.
Hey! Yeah. So yeah, Ethereum's 10-year birthday. So we're going to have it on a Wednesday, and we're still kind of lining up some plans for like where it's going to be held. Got a couple little options, couple things brewing. We're hoping maybe have a little bit bigger of an event. It may not be here. We might have it in a bigger location. But yeah, just a little bit of excitement around 10 years of Ethereum magic. Magic. 10 years? Hey, 10 years, 10K, right? Yeah. 10 years, 10K! Woo! All right. Yeah, so we'll keep you posted on that one. But yeah, we won't be here next week. Summer hours. Yeah, enjoy some sun, hopefully. And then I think jam session was last week, so maybe we'll do it next week. It wasn't this week, so yeah. So I think next week there'll be a jam session. Yeah, if you're down to jam. And I don't know if there's really much else. I was actually chatting with the off-chain guy. So Jake from Off-Chain, he's back in town. So I think he's planning to start off-chain events again, once a month type thing, just to get that going again. So we can keep your eyes and ears peeled for that. Yeah, but those are kind of the main things going on here. So voila. All right. Well, let's dive into it. We've got Anadi here from Obal. Thanks for coming out here today. We've got Decentralizing Ethereum Consensus Layer. So I'll let you take it away from here, sir. Thank you.
Of course. Awesome. Thank you.
Oh, and if you have questions throughout this, make sure you grab the mic, and we'll so that the people at home can hear from you.
Yeah. Sweet. I got lighting. Okay. So today I'll be talking about like how we can use decentralized validators, also known as DVs, to kind of decentralize and secure Ethereum's consensus layer. Should be fine, I think. Sweet. So a little bit about myself. My name is Anadi Bandharkar. I work with the Launchpad and API team. I do product at Obal Labs. I take care of the data side as well. So do a bunch of things there just to keep things rolling. Before that, I was at Covalent, again doing data and research. And I'm also graduated at UBC. So yeah, if you want to connect, you can connect me using the handles there. But jumping straight in. So what I will be covering today is, I'll start off with like how normal validators work so that we can kind of move our way towards DVs. Just to make sure that everyone can understand that. Like how normal validators work, what things you need to spin up a normal validator in Ethereum, or all the hardware software requirements and all that. We'll just quickly run through that. And then we'll find out what is the actual problem using the current setup. And then why you need the decentralized validator and what they do. And then I'll do a small walkthrough or like how anyone can create a wall-distributed validator. And if we have time, probably we'll do a small demo as well. And I'll show different opportunities using which everyone, if they want, can join the mainnet on Ethereum. And what better time than the 10th anniversary. I'll just hold this. So yeah, so when I say scaling Ethereum, like you can kind of divide Ethereum into like broad layers. There's an execution layer, there's data layer, and consensus layer. All of us know quite well about the execution layer because a lot of work has been done around it. All these companies like Optimism, Arbitrum, Starkware are pretty well known with their optimistic and ZK rollups. Recently, we had a lot of buzz around the data availability sampling. You get the likes of Celestia, Eigenlayer doing restaking and all that, and Avail. What for a long time has been kind of not ignored, but just a hard problem to solve is the scaling and securing of consensus layer. And that's where OBOL comes in. So before I talk about the TVs, sorry. Okay. Before I talk about the TVs, I'll just talk about like how small, simple vanilla validators work. So what they do, they secure Ethereum's network. We all know about that. To join and then to create a vanilla Ethereum validator, you need to create this validator, this node, run a bunch of software on a machine, and deposit 32 ETH, which is almost like $90,000 or 120,000 CAD. What does it do? It verifies transaction in blocks and proposes new blocks. I don't know what's going on. Yeah, hopefully it should work now. So what does the validity actually does? It performs three duties. It does the attestations, it does the proposal, and it does the sync committees. So what's an attestation? Attestation is just all the validators voting for the validity of a block for the previous blocks. It happens every epoch, which is like every 6.4 minutes. Then you get the proposal where every epoch, there are a bunch of slots. Every slot, a random validator is chosen. And then that validator kind of groups the transaction and creates a block. And you get the sync committees, which is, again, every once a day, bunch of validators are chosen at random. And then they together form a message. And this sync committee just helps the light clients to stay, to quickly sync with the chain. So these are just like what previously was what a validator does. Now, why anyone should even run a validator? What is the benefit of doing it? Broadly, there's usually two reasons why people do it. Number one is, of course, the rewards. Right now on Ethereum, there is like 2.5 to 3% APY, depends upon if it's a lucky day or not, which accounts to almost 0.8 ETH. So that means that once you put 32 ETH, by end of 1 year, you'll get almost 0.8 to 1 ETH of reward. So the duties I showed before, how do they contribute to the rewards? So almost 85% of the duties, almost 85% of the rewards come from attestations, the first duty. So which is quite counterintuitive because people think that producing block should be the most rewarding thing, but it's not. Then you get the proposals, which only accounts for like 12.5%, and sync committees, which is extremely small, but still not negligible. And the second reason why people run validators is to help decentralize Ethereum's network. So today we know Ethereum has almost 1.09 million validators, which is quite absurd. If you put that in numbers, it's almost like $35 billion or 50 billion CAD, which is insane. So that's what makes Ethereum special. It's not the EVM, it's not the data availability, it's the security it provides. That's why it can be the world settlement layer. And the only way to secure this is by securing consensus. So the way people usually do it nowadays is you need like a decent machine, not a crazy machine like you would need in Solana or somewhere else, but you need like a decent machine with like multi-core CPU, just normal specs, 64 GB RAM and all that. I'll skip that. But where people usually run this hardware is number one is cloud right now. So you will see that cloud almost half to two-thirds of the Ethereum validators will run on some kind of public cloud like AWS or GCP. The remaining like 20 to 40% are run on bare metal. And rest are by solo stakers at home. So the difference is, if you think about it, like why people run on cloud, because cloud is the most expensive option. But people still run on cloud because it's just easy to manage and deploy. usually all these big, massive companies running thousands, millions of dollars of validators, they want to orchestrate all this billions of dollars of money they have right now. So they want low OpEx cost with people. So they use clouds because it's easy to manage, and they can kind of break even and make profit at that scale. Bare metal is usually people who are like small companies just starting out, trying to be part of the Ethereum validator network. They do it. And home hardware is usually the solo stakers. Like people like you, me. I don't run work for a big massive company like Horizon or something. So I usually will be like a solo staker at home. And the biggest blocker for me being a solo staker is the high upfront cost. Not only I need to buy thousands of dollars of the spec, the actual hardware, but I also need to get $100,000 of ETH, which is again quite absurd. So how validator is run from the software side? There are three softwares people usually need. Number one is the execution client. So we'll see just the two clients, Geth and Nethermind. Together made 80% of the Ethereum network. Again, a single point of failure. If anything happens to them, the network will suffer. Execution client just runs the EVM and all the transaction stuff. You get the consensus client. You will see again almost 70 to 75% runs on just two clients, Teku and Prism. Again, if something happens to them, entire network will suffer. And lastly, you have the validator client, which does the duties and everything. So you'll see that these clients talk to each other a lot. Like there's a lot of data sharing happening between these clients. You get the execution client, like kind of bundling the transactions and running the EVM and all that. You get the consensus client, maintaining the state of the beacon chain or the consensus layer, telling like which validator has what duty, who has to attest, who has to propose, who has sync committee and all that. And then the validator client is actually the client which works with the consensus client to actually do those duties. So if I had to again think about the economics of how these companies or how ETH validation work today and why there are like a million ETH validators. So you will see that the initial capital that you need to stake ETH is for one validator is like 32 ETH, approximately $96,000. For 1,000 becomes 96 million. Hardware, if you're doing at home, it's around $800 to $1,500. If you're doing a high-end bare metal, if you want to have your own hardware, some companies do that as well. They just buy these server machines. Still like $15,000, something insane. So these are the fixed costs. Operating costs are, again, if you think about it, if you run on cloud, it's like per month for one validator is like almost on average $300. And then for thousands of validators, it's not increasing proportionally, but becomes like 10 times. So the reason I'm showing these numbers is if you look at the very bottom, you will see that around this part, the annual ETH APY of if you put almost $100,000 of ETH, you get almost $3,000 in USD in annual rewards, or almost like 1 ETH in rewards. If you think about from just purely economics perspective, it doesn't make sense. Like just 3% reward, like you'll be better off putting that money in a savings account. So why people do that? Because they're long on ETH. That's as easy as that. They think ETH will appreciate more than US dollars in coming year, so they're doing it. And it's kind of working out because there is almost 1 million ETH validators right now. So what are the problems with all this? Like all this this thing I showed, what is the problem? The first biggest problem is the financial barrier, the economic barrier. Like you need almost 32 ETH, almost $100,000 to be part of the ETH validator network, which is by itself is a big blocker for a lot of people. Then and it's a very complex path to mainnet. Like how will you do all this? How is it all possible? And even after assuming that you end up running it, if you don't do your job properly, you end up getting penalties. So if you started a validator and if you have a downtime, the internet is not working or something goes wrong, you will start getting penalties for inactivity. A lot of these companies, what they do is that they have an active passive system. by which I mean that like they have an active validator which has the keys and everything, and they have a passive validator which is running but doesn't have the keys. If in case the active validator goes down, they just transfer the keys to the passive one because they don't lose any rewards. They don't want to get penalties because because we saw in the previous slide, they are operating on a very small margin. So they don't have any room. They want like a complete 100% uptime, no issues at all. But because of this active passive kind of setup, what sometimes happen is that when these people transfer the keys to the new passive validator, which becomes active now, the old validator sometimes come back online by itself. Something could happen. Maybe there was just a bug or something that now there are like two machines with the same keys. And Ethereum doesn't like that. It thinks you're being malicious and you get slashed for it. And that's like one of the penalties called as double signing. And the lastly is the correlated slashing. So when slashing happens, for 36 days, your validator becomes idle, doesn't do anything. And during this time, Ethereum kind of sees how many other validators are getting slashed in the network. It was like a correlated kind of event. A lot of people are getting slashed. And this is proportional. And this could be the worst penalty. That if one, for example, if one of the Geth client here, less than 50%, all of the people running Geth, 50% of the network gets slashed, the penalty will be exponentially high. So a lot of people will just lose insane amount of money. So slashing, no bueno. So Ethereum team kind of always knew that these are the problem. It's not like we are discovering it. So that's why this is like a snapshot of the roadmap Vitalik published a while ago, I think around merge. And you will see that here, around here, he kind of mentioned DV, that they have to happen. It's like a part of an Ethereum roadmap. And that's what overall worked on. So enter DVs. On the left, you will see here that how today a normal validator is run. Is you get a single machine which has all the clients, the 3 clients we just talked about, and you have the key, the private key of the validator. And when they all come together and you deposit 32 ETH, you start producing the duties and you start producing the blocks. What a distributed validator does is that it split the keys into private key shares. So none of the node here has the access to the entire key. The only way now you can be part of the network is that you form a consensus. And this changes almost everything. So what happens right now is that previously, if this machine goes down, I will start getting penalties for inactivity or slashing or whatever. But now, since I have like 4 machines, kind of 4 nodes working together as one validator, and I've split the keys. Because of this, if one of the node goes down, the 3 of them can still come together, form consensus, and keep producing blocks, and keep doing attestations. So there is no downtime. And it's a very common practice in computer science, but we're just bringing it to the validators. So what we have done right now is that from active passive redundancy that we had before, where we had like one active machine, one passive machine in the previous case, and we were kind of moving the entire keys between them. Now there's an active redundancy. Is that all the 4 nodes are working together. They all have the shares of the keys. Only 3 out of 4 have to come together to form and do duties. If one of them goes down, we're good, and you can take a good night's sleep. And this kind of changed a lot of things for the customers that we have. So that brings me to Charon. So 2 days ago, we released Charon 1.5. Charon is our client. Just like Geth or Nethermind that you saw before, it's a client that sits between the validator client and the consensus client, and it kind of intercepts their messages. And it helps 4 different nodes. Awesome. So it helps 4 different nodes to come together and form this single validator called as a DV. So the first thing that we saw is it's a middleware. It doesn't really changes architecture drastically. It just comes inside your existing stack. It just slips in your current architecture that you're already using. So it's a middleware. It doesn't cause a lot of problem. Second thing, you will see that it enables client diversity. So all the issues that we had previously with the clients, that there was so much concentration for Geth, so much concentration for Nethermind in the EL and so on. You can kind of in a single cluster run multiple clients, and because of this, the ratio of the clients changes very quickly. Second is DKG, or distributed key generation ceremony, which is just a fancy way to say that the single key can now be split into private keys, separate private keys. And so no a single person controls the, I don't know what's happening. So no private key kind of controls the entire cluster. And lastly, there's no token risk. So there is usually, if you see other DVT clients out there or other DVT protocols, to join their network, you have to also have like a token to be part of that network. Or do you also need to have, and that just puts an extra variable operating cost for the validators or the operators, which are already going through a bunch of OpEx expenses right now. So there's no extra token needed. Like we believe the ticker is ETH. So what it enables? Yeah, let's go. So what it enables is first is Raver. So Raver is a score that is used to grade validators' performance. It's a quite well-known standard in the space. So you'll see that traditional validators almost average Raver is around 97.35, and I think this is an all-time Raver. And what you see here is the Raver score of almost like $600 million of validators right now being run on Lido using OBOL. So Lido uses OBOL at the backside. You see the uptime, so you almost get 100% uptime with the OBOL DVs. You see correctness has also improved. When you see these numbers, they don't look too much because they look like it's like 97.35 and 98.63. It's like barely any difference. But for a validator or an operator which is working on such tight margins, every basis point matters by a lot. So this is actually quite big. And you cannot probably see here, but we've been live on Ethereum for almost like 2 years now, securing almost 1.5 billions and all that. So I'll just jump into this slide. So this is the recent update. The total ETH that is staked right now on World DVS is 700,000. If you put that to number, it's almost like 2 billions right now. Hopefully, by the end of the year, we can reach 10 billion, and I think we're on track for that. We almost have 700 operators. So previously, when the concentration of the operators was just like these big professional operators running tens of millions of dollars, we kind of helped Lido decentralize it. Right now, there are 700 million operators on mainnet, and there are also like almost 5,000 technical credential holders. I'll come back to this again. So how to create an OBOL DV? Charon, I already talked about what Charon is. It's the client that we have developed, which allows this kind of architecture. We also have the OBOL SDK and Launchpad, which is the way you can kind of launch this distributed validator. And lastly, you have the OBOL splits. So like when 4 people create a distributed validator, they also will need to split the rewards. And the OBOL splits are the smart contracts which enable the splitting of the rewards non-custodially. So they can do it all themselves. So if I categorize it into broad categories, the first thing is the setup. First thing that user will do is find like a bunch of 4 people, 5 people, whatever you want the cluster size to be, and you use the launchpad that I'll show, or the OBOL SDK. And you can create or accept a cluster invite, whatever you want. And once you formed a cluster using the invites and all that, I'll show the flow after that. You will do a DKG to generate the private key shares that I showed in the previous slide. Once you have created the cluster, you all have your private keys. The next step will be getting the hardware, installing clients and all that. You can use our CDVN for it. I'll show that as well. But then after that, once everything is set up, you'll deposit 30 ETH. Once you deposit the ETH, your validator will become activated. Now the job is to monitor and maintain it. You cannot just leave it. For most part, nothing bad will happen, but you still got to monitor. It's like, for example, if you release a new version. Oh. Weird. For example, if you release a new version, you will have to kind of grade your new nodes. And doesn't have to be that all the nodes can be upgraded, have to be upgraded at the same time. You can upgrade that at your convenience, because it's all backwards compatible mostly. Lastly, you will use our split contracts to split the rewards. And if you want to exit the validators, you can use Heron to exit it.
Quick question. With the 32 ETH, when that it just keeps track from each, I guess, collectively. So like if I'm depositing, and is there fixed amounts, or can it be like, do I have to deposit even numbers? Can I just deposit like 5.62 and somebody else adds whatever else, or how does it keep track to make sure it's exactly 32?
Yeah, that's a good question. So we don't keep track of who deposited how much. Usually what people do is they create a safe wallet, and using that safe wallet, they all have the access to the safe wallet. For example, 4 people, if you want to deposit 32 ETH, they'll create a safe wallet with, let's say like equal 4 ETH, 8 ETH each. They'll put all that into the safe wallet, and when the rewards come, when they have to split the rewards, they can use the splitter to split 25%. But the principal, if you want to split the principal as well in the same proportion, so we have 2 configurations, which I'll show in the launchpad right now. You can split the rewards only, or you can split principal and rewards. So you just have to put the ratios in that percentage, and it will work for you.
Okay, and then now that with Pectra now, we can have more than 32 ETH. Are you going to get to that? Is that coming, or is like, how does that work now? If everybody wants to deposit 10 ETH, and have 40 ETH in a 4 model. You guys support more than 32 ETH now as well. Yeah,
we do right now. Like it's not live. You will not see it. Like we have the dev version of the launch and everything where it's supported. We're building it. So we have developed a new contract called as OVM. And what it does is like it enables all the Pectra features that you can deposit more than 32 ETH, almost around like 2048, whatever that number is. Supports that. It also allows you to do the EL exit. You can do that too. You can do consolidation and everything using the contract. So it manages all that using roles. So there will be an owner of the contract, and that owner will give role to someone else. This guy can withdraw, this guy can consolidate, and all that. We can be like very granular with it. So a lot of people is going to use it because you can now also tokenize a validator using it quite easily. Yeah.
And I guess you could even do this yourself, even if you just ran your own cluster yourself, saying like, okay, I want to run, because if I'm running one validator with all of that, like if I wanted to could put all my rewards together, I could say, all right, instead of me having each validator at 32 ETH or running them all on one machine, I can run them on 4, but then they're all collectively together in the same pool, but I'm actually running, what's 32 times 128, I suppose. And then I can just have all the rewards piling in together, paying to the same address with all 4. And then I'm actually making myself more decentralized in a way. I'm going to switch this for you. But okay, cool.
Awesome. Sweet. So you can scan this and you can go over the launchpad as well. But I'll just use, already have everything created here. So these are the docs. I provided all the links, so you can check them out later on if you like. But so these are the docs. The very first step that you have to do is just find this GitHub repo, copy it, and do the Docker run to create ENRs. So I've kind of already done all that, so I know it would be very strange to do all this here right now. So this is the launchpad. You get 3 options. You can either create a cluster with a group, where you can like bunch of buddies can come together, form a cluster. You can create a validator alone as well. In this case, you won't do the DKG because you already have all the shares. Here, your main purpose is to just have fault tolerance. And lastly, you can migrate the cluster or migrate the existing validator into a DV as well. And a lot of people are interested in doing it. Recently, Lido announced that they want to use DVs to migrate the existing curated set, which are running like billions of dollars, into Vault DVs. So if I
just quick again there. What how much Lido, or how much is Lido planning to allocate towards DVs?
so it already has a simple DVT module going on, which has I think almost around $1 billion in it.
The billion, and is that like that's the CSM?
No, so that's different.
That's different. Sorry. Okay.
So it's simple DVT is already, it's like a separate model just for DVTs. It's curated, operators are brought together, picked by Lido and us.
Got it. Okay.
And there's your CSM, which is permissionless, so anyone can join it.
Right.
And yeah, I mean, that's the best way to go to mainnet. I'll come to that as well. So this is just a quick walkthrough of the of how the launchpad looks like. The first thing is you get the T's and C's. I'll accept them because I know what they are and I made them. So I agree all that. Awesome. So the first thing you will do is create the cluster name. I'll just put whatever name, then T. And you have the cluster size. So I'll create like 4 nodes for the cluster. Threshold will be 3 by 4 from this. Operator addresses. So I'll start pulling it. And that's fake ETH, so don't worry about that. Yeah, that's all Huri. You need that for canary testing. So I'll put like 4 addresses here who in the real world are actually different addresses, like different people. But I'm doing it all here just to show it. So just put 4 different addresses, and then I have to generate an ENR. So this is what docs talk about. It's how to generate an ENR. So the way DKG works is that all these 4 nodes will have to create an ENR each, which kind of identifies these nodes to each other. So when they expose each other to the network, they can find each other and do this DKG ceremony. So what is the Caron? I have this thing right here. So I'll just copy the command from here. And it will just generate me the ENR here. Just copy this ENR and just put it here. Yeah. And now it comes to the actual rewards part, the withdrawal configuration. So the split contracts, they're like 4 different configurations here right now. Either you can split only rewards. So what happens in this case is that you put 32 ETH principal, and only the rewards will be split among the 4 people. The principal again just goes to the address that you've chosen here. It will not be split. You get split everything, where you can split the principal, 32 will be split as well, and also the rewards. And lastly, you get the Lido CSM, which Tango was just talking about. So I'll just use my address here and paste all the oppressor addresses. Let's put random numbers, 24. Just a review page, and then I'll deploy the split rewards contracts, which of course is an issue. Anyways, usually it works. I'll not inspect it right now. Anyways, I created the cluster already before I came here. So what will happen is that when I deploy this contract, I will have to go through each and every address and then accept the invite that each and every address will get, and it will lead us to a page for doing the DKG ceremony. So I can show it here. So I accepted all the configurations here. I got an invite, and I can do DKG right now. So this is the command to do the key generation. So I had 4 terminals open here with me. I made the eners for all of them before and did all the invite stuff. And all I do is do the DKG. So using that, they're connecting to each other using the eners. And then we'll start the ceremony, and it will finally create the private key shares, hopefully. Awesome. So all the key shares were created, and the cluster can be found here. So you can see the status right now. It's not active. Nothing's going on. There are 4 operators. You will see the withdrawal address, which is the contracts we created here. You can distribute and claim rewards, and you can exit the validator. It will give you all the flows right from your dashboard. What I want to show really, and that kind of talks about the opportunities, is how anyone can be part of the Ethereum network. So you'll see this thing called as technical credential here, which I also talked about before. Almost 5,000 people are part of this now, and you get the badges. I will not go into the badges, but I'll show Techni again. So how can anyone get a path to mainnet? Because there are a lot of barriers to it. We talked about them. There are like economic barriers, technical barriers, and a bunch of things. So what Technical Credential do is that it provides opportunity for these interested people, a path for the delegated stake. And where this delegate stake comes from, it comes from the big protocols that we know of, which is like EtherFi, Lido, and all these people. They use operators who have these technical credentials. So you learn, you experience, and you earn. Quite straightforward. So opportunity 1 is Lido Simple DVT, which I just talked about. So experienced home operators can earn this. How does it usually happen is we run cohorts and batches of people who, if they want to be part of the mainnet validator, they join our cohort on the testnet or hoodie. We'll give you the fake ETH and everything. And all you have to do is form a cluster and run this DV. And then we'll monitor your on-chain performance, how good was your raver, how good are you in troubleshooting issues and all that, which we discussed with Lido are like the utmost requirements. Once you prove a good raver score, good performance, we give you a technical credential, which is the bronze technique. Once you get this bronze technique, whatever the next wave comes in for Lido Simple DVT, you will be a candidate for it. So Lido can pick you from that. And then you will not bring any of your ETH. Lido will give you the delegate stake ETH to run the clusters. So you can be part of Lido. And that's how Lido is right now decentralizing their operator set. And they started with 7. And there was a lot of issues with Lidos back then, but right now they have hundreds of operators because of this. Second is the squad staking. So all of us, bunch of us just come together and be part of Lido CSM right now. It is permissionless. There is no curation, no handpicking, nothing. It is the easiest path to mainnet and to get a silver credential that we'll talk about later on. But the economics is quite straightforward. You only need 2.4 ETH of bond. And when you split that among 4 people, which is like only 0.6 ETH for the host validator, anyone can become if you just gather like 4 people. And for the following validators, it becomes 1.3 ETH, which is a lot less, like 0.3 or 0.4 ETH for a single validator. So which is, I think, affordable, a lot affordable now. And you share rewards with Lido again. Anyone can be a part of this, just like I talked about. And today is the easiest option to reach mainnet. Third is, once you get a silver technique, so you get a silver technique credential when you are on mainnet. And once you're on mainnet for a while, we'll give you a silver technique showing that you actually proved performance on mainnet too. And now EtherFi has adopted picking its operator set from all silver technique holders right now. You can see the economics there. There's no bond, just like Lido Simple DUT. It's all delegate stake, and you can earn like $200 per month almost. And there are more opportunities coming soon as well, which will keep giving to these techni holders. But what this really does is not only we have the demand side with like Lido and all the protocols and out there, but we also have now a big supply of operators who are good in running all this hardware and validators. And if you think about it, not just Ethereum, but there are also other protocols out there, other chains out there who want to decentralize, let's say, their sequencer, decentralize their own chain right now, relative to whatever it is. And they can tap into it. And that's why we introduced a few months ago a Vault Stack. So it is just like a managed Kubernetes Helm chart kind of architecture where you just install this on your machine and it explodes the opportunities for every single thing out there. It can be a decentralized sequencer, it could be some other L2 or some other chain out there, it could be an AI agent which is getting hype, could be anything. So that is the most recent thing that we have been working on, and it's going really good as well. And if you want to be part of this, if you're not just join the alpha for the Vault Stack, you can scan the QR code and you can join the alpha list there as well, and that'll be your part to mainnet. That was it. Thank you.
All right, we can open it up to some questions. I did have one more. It was around. Just go back like 2 slides. One more. Oh yeah, I guess it was just like around the credentials. So are those like? Are you getting them as NFTs?
Yeah.
Are you getting and are they soul bound?
Yeah.
So yeah, so you couldn't transfer them. So it's like you're knowing that they're on that validator.
Yeah. I guess the only thing you can do is sell your private key.
Right, sell your private key,
so you can do nothing about it. But we are trying to introduce like more like proof of humanity, ZK passport, and all that to it in the future. There's no demand for it, so we're not working on it.
Yeah, of course, but that makes sense to try and have the proof of humanity with it. I guess like the other thing you can do too is like have a one-of-one multi-sig and then like transfer the ownership that way too, I guess. But if we get there, we get to if it gets that crazy enough. Okay, yeah, good to know. Good to know. Anybody else? Questions? Got a mic here.
Let's say I form a cluster with my friends, and then one member of this cluster, we need to kick them out.
Yeah.
Do we need to do, how do we do that? And I assume we need to rerun the DKG ceremony, huh?
Yeah, right now, we're working on that exact problem right now, is that how can you do it without a new DKG and just kick someone out from a cluster and bring a new guy in. But right now, yeah, you will need to do DKG again. And what you can do with Pectra is that with all these current validators that you have in your source cluster, you can migrate them and send all the stake and consolidate them to the new cluster. So you form this new cluster with like some other friend who responds better, and then you do DKG again for the new cluster, and all the stake from the old cluster you can just consolidate into the new cluster.
Okay, and now what if the majority is just colluding against an honest minority? That means that they can't like pull out their portion of the stake, right?
Yeah, that's not, you can't do anything then.
Like the inverted scenario. All right.
What's the future upgrade on Ethereum after Pectra here? Aren't we talking of bringing down validator limits from 32 down to like 4 or quite a bit in the near future?
Yeah, there are talks around it. And if it happens, it's good for us. Like that just brings the barriers down. Like for example, with Pectra, there were the slashing penalties almost like, it was like almost 1 ETH before, and it has gone in like 1.1 or 0.01 ETH. So they, as the network progresses, I've seen that they do all these changes, but all the changes are turning out to be kind of better for DVs, except then the only one we're confused about is the beam chain. Because when beam chain comes in, it kind of is changing the entire cryptography. So right now we use BLS signatures here to split the keys, and BLS is the same signature that the aggregated committees and all they use. So once the beam chain comes in, then the issue might start. But we are again working with the beam chain team to make sure that they kind of think about DVs as well, because like a lot of people's livelihood now depends on DVs.
And to your point there, if we go down to 4 ETH and ETH to 10K, so it's still 40K, right?
There you
so
go.
yeah, there we go. We're gonna need to break it up even further then. It'll be like half an ETH for. Okay.
What are the economics of Obol? Like, what is the cost of integrating Obol as a validator as a home staker, I guess?
That's a really good question. Let me show something. Hopefully, the launchpad is still open. So when you create a validator, how does Obol makes money? First of all, is it's on a hoodie, but the same thing is on mainnet. That when you create the splitter, 1% or 0.1%, it depends upon like the partner. The reward goes to the Obol, and that's how we take our share of it. And what happens to all these validators right now is, if you think about it, let me just show this all over again. Previously, the same thing which could be run on a single machine now needs 4x the operating cost. And that is a very valid concern. So the way we kind of propose to solve it is usually the same single machine. It's not ever a single machine. You always at least 2 machines for the active passive redundancy. When that happens, it's run on cloud so that you can programmatically turn it on and off. When you have the active redundancy, now you can run it all on bare metal. So the cost goes down 70-80% already from itself. So that's how, even though you're running like 4 times the hardware and the software and all that, effectively the cost goes down.
So is there a limitation in terms of the amount of DVs that you can have? And are you also looking to expand into different other protocols, like, or are you just going to stay on ETH?
No. Like ETH for sure will capture as much market as we can, because this is the home for sure. We already are live on Gnosis because it is like if there's any EVM chain it can use, kind of. It depends on the block times and all that. We kind of have to finesse it. But for most part, if it's EVM, it can be done. We just have to invest time and money to it. So we did a POC with Gnosis and it worked. We had like hundreds of validators on Gnosis. On the limit, we have clusters running like 2,000, 5,000 validators. And it can be done because it's like a small cluster and all the messages are between those 4 nodes. If it was like a big network, which other duty protocols are, then you have to do the gossip sharing between all the nodes. All the message goes between all the nodes of the network, which is a problem. So this cluster is isolated. And this kind of comes together as one single validator for the entire network.
Looking at this, I just thought of something. Are you able to like fall back if, say, there is problem with middleware, networking, or something wrong with Charon? Like is an individual able to fall back to something else or no? Like once the networking is, or like maybe there's a network partition for, I don't know, 50% of the cluster.
Mm-hmm.
Like is there some kind of mode or resilience for that, or
so
emergency?
For different kind of fallbacks, we have different options. For example, if someone is running a beacon node here and their consensus client goes wrong, like something happens, we don't know what. So we provide option for a fallback beacon nodes. You can have like 2 beacon nodes running. If let's say something goes wrong with Heron, so we are working with other teams like Nethermind to create another version of Heron, but completely separate, and they'll do it on their own. So it will be Chiron, but on a different language by a different team. It would all be kind of governed by OBOL. So you're not going the same problem that you started with.
Yeah.
Yeah. So we'll make sure all that is taken care of. And we have like several fallback options. So for example, if you want to go back to, let's say, a single vanilla validator, you can recombine the private key shares into a private key and just turn all this off and go to this. You will have some downtime, but if that's what you want, they can do that too.
But I have to be able to transfer the shard or the portion, right?
Yeah, like if you're working on
like all the operators in that cluster need to agree to do this.
Anything will happen now will be using democracy. You have to form majority. Always.
But they have to assemble the key again. Okay, yeah.
Mm-hmm.
All right, cool.
All right. Okay. Probably a great place to wrap there. Yeah, once again, thanks again so much, Anadi. Yeah, very awesome to see all this. Okay. Well, we will catch everybody in 2 weeks from now. Remember, every 2 weeks. We're doing it for the summer, so a couple of weeks. And then, get ready for the 10-year 10K. Boop, boop. All right. Thanks for coming out, everybody. And if you don't mind, just fold up your chairs and hang out for a little bit. Okay. See ya.